Hey everyone, welcome back, JavaMentor.net here. Let's learn about abstract classes and interfaces. First, let's repeat once again what is a specification and what is an implementation. So I just created one very simple tax calculator and I wanted to invoke that tax calculator to give me a net amount of my salary based on the gross amount. And as you can see, there is a method called calculate net amount, and I need to pass my gross amount salary and I need to pass am I a US citizen or not. So based on those parameters, this will calculate me a net amount. And this is what's a specification. What will be done? So net amount will be calculated based on those parameters. You can see that specification here, signature of the method. And how it will be done, we can see between those brackets. This is the implementation, how things will be done. So in our case, it's very simple. If you are a US citizen, we will take a little more tax from you and so on and so on. But nevertheless, here you cannot see implementation. You only see what is a specification, what needs to be done, not how it needs to be done. We also learned in the previous tutorials about extending classes, so one class can extend another. You remember the example with person and student extending person. But what if we want to separate specification and implementation? Let me give you a concrete example. So I created one class vehicle with some ID field, and every vehicle has a price, right? So I created a method getPrice and I just hard-coded 0 here. And there are two types of vehicles. Let's say there is a bicycle and there is a car. We determine the price of the bicycle depending on does it contain a support wheels. Those support wheels are those small two wheels that are meant for kids, right? So let's say if a bike contains those, then it's $500. If it doesn't contain those wheels, it's $400. I mean, we can do some complex calculation here based on wheels, based on brand, blah, blah, blah. But the point is that we are calculating the price based on bicycle attributes. The same is for car. Let's say that cars with electric engine are a bit more expensive, so if it has electric engine then it's one price, if it doesn't it's another. But also again we can have a price on car based on brand, based on the things that car has. But the point is there is no way to calculate a price on vehicle. And that's exactly where implementation specification things comes in. So we know specification for vehicle, we know that every vehicle will have a price and every vehicle will have a getPrice method that will return some price which is integer or double or whatever, but we don't know inside the vehicle how implementation is done. Implementation is inside car and inside bicycle. That means that we will omit implementation here, so we will just do semicolon instead of implementation, and Java will complain. It will be red, it will tell us declare abstract, please. Okay, this is now abstract, which means it doesn't have an implementation, but you cannot have abstract methods inside a regular class. Class must be abstract as well. Okay, now everything is fine here, and we implemented implementation inside car and bicycle. Let's move to the main class and try to create one vehicle, right? So let's say we are creating a bicycle, and as you can see on the vehicle reference, so this is vehicle, not bicycle, we can call getPrice method, because there is a specification inside vehicle. Vehicle has a specification. It will have getPrice method, and depending on which object you assign to that reference, that method will be called. In this case, it will be called a method of bicycle class. If we just go here car, now this getPrice will be the method from the car class. Okay, but what if we try to say vehicle equals new vehicle, right? Which method will be called? Because as you can see, there is no implementation here. Well, for that reason, namely because there are no implementation for some methods, there is no way to figure out which getPrice method to call here, and for that reason you cannot instantiate an object of a vehicle class. So you must either instantiate object of a car or a bicycle. So you cannot instantiate object of an abstract class. Let's imagine for a second that for every vehicle we want to know, does it comply with European Union standards? So we can go the same way as with price. Public abstract boolean comply, actually we can say satisfy EU standards, right? And also we want to have one method that say satisfy ecological eco standards. So those are two methods that we also want to implement inside car or bicycle. But there is one problem. If for every behavior that vehicle can have, we add one method like this, well, very fast we will have this abstract class with 15 methods or more. And the even more obvious issue is that, well, eco standards and EU standards, they're not related to price. I mean, those are totally independent things, right? Also to mention that those eco standards and EU standards, those can be applied to laptops as well. So not only for vehicles. So we need some way to extract this contract, this specification, and then apply that specification to our vehicle class. And that's exactly what interfaces are all about. Okay, I will create a new interface, echo standard, and I'll say interface. And then inside this interface, we will introduce this satisfied echo standard method. Also, you can see that public and abstract are gray because by default inside interface everything is public and everything is abstract. So you can omit those two words. And what now? Well, let's say that I will just delete this regarding EU standards because it was just an example. So we want to apply this echo standard to vehicle. No problem. This vehicle implements echo standard. We created a specification echo standard and we applied that specification to our vehicle. But we now must write an implementation. An implementation will write that inside bicycle and inside car, right? Now you may wonder, okay, but we applied echo standard to vehicle, why we don't write implementation here? Well, we can do that. As you can see, override method, we can do this, but the point is overriding methods is not mandatory in abstract classes, as you can see, right? And that is why Java is, and inside concrete classes, of course, inside methods that are not abstract, you must write an implementation. That's why here it's not compiling, right? So you can override here satisfy echo standards. And in this way, now you can apply this echo standard to laptop as well, of course. Let's say laptop implements echo standard. As you can see now, this is complaining. It wants you to override some methods from the interface. Now it's not complaining anymore. This annotation is not that important. Even without it, everything will work fine. One important thing to mention is that one class can implement multiple interfaces, but one class cannot extend more than one class. So you cannot say extend car and then extend, I don't know, bicycle. It will tell you class cannot extend multiple classes, but you can say implement comparable, that's interface from Java, and implement echo standard. That's fine. It will just ask you to implement this compare to method from the comparable interface, and everything is fine. Everything is compiling. So the last beginner-friendly advice is that interfaces are more flexible because you can implement more than one interface and you can only extend one class. If you have any problem and you need to choose between abstract class and interface, I'll tell you, try to solve the problem with the interface. If you cannot do it, then switch back to abstract classes. I mean, choosing between those two will come with experience. Don't worry too much. It's important for you to realize that both abstract class and interface, they are solving the problem of decoupling specification and implementation, and those are two different ways to do that decoupling, and that's it. Use one, use another, try, experiment, and things will come with the experience.